Question 12. Sarah's parents are concerned that she seems short for her age. Their doctor has kept the following record of Sarah's height. So her age has been recorded at 6 different times, and her height as well. Part A, make a scatter plot of these data using age as the explanatory variable. Describe what you see. All right, so I'm going to switch things here. I'm going to just change the, how do I separate this? Let's try this instead. I'm right-handed, so I just want to have the, I'm going to want to write on the right side. So I'm just going to switch things around there. Okay, there we go. All right, so make a scatter plot of these data, which we've done here in Staplet, and then describe what we see. All right, so I'm noticing a pretty strong positive linear relationship between Sarah's age and her height. I notice that there is an unusual point at 3686. Right, even though that point follows the trend, it's a pretty big gap between when that measurement was taken and when all the other measurements were taken. All right, so let's go ahead and record that down. There is a strong positive linear relationship between, is her name Sarah? So yeah, Sarah's age and her height. The point 3686 is unusual in the sense that it is low in both x and the y direction. However, it still follows the general trend of the other points. Okay, so still follows the general trend. Okay, part B. Use your calculator, find the equation of the least squares regression line. Okay, well, I'm not using the calculator, I'm just using the software here, and this is the equation. Okay, so it's the predicted height. Okay, remember we want to include context even in the equation. 71.95 plus 0.3833 times her age. All right, part C. Calculate and interpret the residual for the point when Sarah was 48 months old. Okay. So let's input 48 into our equation here. Let's see, I don't think I need that anymore, so I'll make this full screen. All right, let's duplicate that and then replace age with 48 months. Okay. So her predicted height is going to equal 7195 plus 0.3833 times 48, 90.34. And this would be measured in centimeters. Okay, that's her predicted height. The question said find her residual. Okay, so the residual is the actual minus predicted, which in this case, what was her actual height at 48 months? It was 90. Okay, so 90 minus 90.34 is equal to negative 0.34. Right? So the prediction was only off by less than a centimeter. So pretty good prediction. All right, part D. Would you be confident using the equation from part B to predict Sarah's height when she is 40 years old? Explain. Well, 40 years is equivalent to a lot of months. 40 times 12. 480 months. Okay. Now, 480 months is much larger than any other input value we have. Okay. So I would not be confident at all. In fact, what question D is testing you on is your knowledge of extrapolations, right? This would be a severe extrapolation. Okay. In other words, it would be a prediction that might not be very accurate. We shouldn't have a lot of trust in that. Now, if you think about how humans grow, right? Humans have kind of a growth spurt when they're young, and then when you reach adulthood, 18, 25 years old, you don't stop growing anymore. Your height kind of plateaus, right? So yeah, I mean, we might be able to use the model, in her, child and teenage years, but in adulthood, right, she's not going to keep growing at the same rate that she grew as a child. Okay, so yeah, I would not try to make that prediction.